Okay, there seems to be a lot of trouble with this problem. Let's see if we can help you figure this out. You've been given a cube, yeah, which is aligned along the x, y, and z axis as shown, and the points A, B, C, D have been described. You've been asked to use vectors to compute the angle between AB, which is along the z axis, and AD, which is the longest diagonal in the cube. Okay, so how do we go about this? So here's a representation of the cube. I'm assuming that the cube is of side M. Let's see what is the angle we want first of all. Okay, first is this is AB, this is one vector, and this vector along the diagonal is AD. Okay, we want this angle theta. Okay, so the first job is to write down the two vectors AB and AD. If the side of the cube is M, yeah, so all these pink lines are M in length. Therefore, A to B is going to be M, and therefore vector AB can be represented as MK hat because it points along the positive Z axis. Okay. The magnitude of this vector AB is simply going to be M because it has only one component. Let's talk about AD. To get from the origin A to this point D, you first need to move M units along the x-axis, then M units along the y-axis, and then M units along the z-axis, right? So therefore, you could represent this vector as Mi plus Mj plus Mk. What would be the magnitude of this vector? It would be under root of M squared plus M squared plus M squared. That's under root of 3M squared, which is root 3 times M. Okay, what's the formula for dot product? Let's find the dot product of AB dot AD. Okay, and look at the two vectors. As you know, it's only the k components, yeah, like components, or the products of the magnitudes of the like components that will stay. The common components between AB and AD are only k, and therefore the dot product is going to be this M times this M, which is M squared. That's what we've got here. Okay, what's the magnitude of AB and AD? We've already figured out here. Finally, theta, as we know from dot product, is going to be cosine inverse of the dot product divided by magnitude of A, divided by the first vector, divided by magnitude of the second vector. In this case, the first vector is AB, second vector is AD. Alright, plug in the values. The dot product is going to be M squared, this M times this M, yeah, that's going to be M squared. Magnitude of AB we've said is M, so that M goes there. Magnitude of AD is root 3M, and that goes here. The M's cancel out. What you're left with is cosine inverse 1 by root 3, which works out to 55 degrees. Let me know if this is not clear.